Today we shall begin with the chapter number 1. As such, your test will be there at the end of the month and the government is going to send you the paper. Okay. So the chapters for this test is 1 and 2. Okay. We have completed half of the portion of the third chapter. Now we just keep the halt there. Okay. The new portion is beginning after this completion of first chapter. Okay. And the things which we have discussed in third chapter generally till now is the course which you have studied in your 10th standard. One or two things are new for you. Okay, the series connection and parallel connection of cells and the temperature dependence of resistivity. These are the two things which are new for you, but we just keep the halt for it. Okay, we begin with this first chapter because it is there in your test. Okay, now the chapter is electric charges and field. Okay, generally electric charges are of two types. You know that there is a positive charge and negative charge. This we are knowing. This is not new for us, but the history will tell us. The history is given in this chapter in the beginning, how the charges were invented. Okay, positive charge is proton and negative charge is the electron. Proton is generally found in the nucleus. Electron is moving around the proton in different orbits. Okay, now whenever there is an exchange of charges, then the electron is removed from one substance and it is removed from one substance and received by the another substance. So the substance which is losing the electron will become positively charged because negative charge is lost, so it becomes positive, and this substance which receives the electron becomes negatively charged because it is accepting the electron or receiving the electron. Okay, the charge on the electron and proton is same. The charge is 1.6 okay into 10 to the power minus 19 coulomb, where coulomb is the unit of electric charge. For proton this charge is positive, for electron this charge is negative. Okay, they are the opposite charges which are having opposite nature. Okay, that is why positive negative names are given. Okay, the charge on both the particle is same but opposite. Okay, coulomb is the unit. How is it defined, that we shall discuss further. Okay, this is the value of the charge. Charge is an undefined term, it's a basic term. Okay, like a point in your geometry, point is an undefined term. Similarly this charge, okay, the term charge is also an undefined term. Okay, the value of charge is same for both negative and positive, but the nature of the charge is different. These are our common understanding, and now we go according to our textbook. Historically, the credit of discovery of the fact that amber rubbed with wool or silk attract light objects goes to Thales Miletus, Greece, around 600 BC. The name electricity is coined from the Greek word electron. This is a Greek word. Electron means amber. Electron means amber. Okay, so if you rub the amber with wool or silk, then they have, or rather amber is having the capacity of attracting light objects, and this amber is known as electron. That is why this term is coined. Many such pairs of materials were known, okay, which on rubbing could attract light objects like straw, pith balls, and bits of papers. You have seen this, bits of paper attracted by the comb when it is rubbed with your dry hairs. Okay, you can perform the following activity at home to experience such an effect. Cut out long thin strips of white paper and lightly iron them. take them near a TV screen or computer monitor, you will see that the strips get attracted to the screen. In fact, they remain stuck to the screen for a while. Okay, so when we keep our hand close to the TV, which is on for a long time period, then the hairs on your hand are also attracted towards the screen. This is our common experience. Okay, this is a picture which is showing the whole process. Okay, first of all, the silk thread is taken and the glass rod, plastic rod, okay, they are tied with the support with the silk thread. Okay, now glass rods are rubbed with the silk cloth. Try to understand. This is for the understanding, just to keep in mind. Glass rod is rubbed with silk cloth or wool. Okay, and plastic rod with the cat's fur. It is rubbed. Okay, they are tied in different way. Two glass rods are there. They are rubbed with silk cloth. Okay, tied with, one is tied with the silk thread. The other glass rod is brought to this glass rod which is tied. Now this glass rod which is tied with the silk thread will get repel, or it will go away from the glass rod which you are bringing close to it. So we can say both these rods are having like charges. So like charges repel, as you know. Okay, if say for example one plastic rod is kept which is rubbed with the cat's fur, if you bring the plastic rod close to this plastic rod first, say this is first class plastic rod, this is second plastic rod, both are rubbed with cat's fur, then this rod which is tied with the silk thread will be repelled. Now if you bring the plastic rod close to the glass rod is rubbed with silk, plastic rod is rubbed with cat's fur, they both are attracted. So we can say they must have the opposite charges. So we can say like charges repel and like charges repel and unlike charges attract. This we can conclude. Okay, okay, so this part you can understand easily. Okay, when a glass rod is rubbed with the silk, the rod acquires one kind of charge and silk acquires the second kind of charge. Okay, glass rod is acquiring one kind of charge and the silk is acquiring the other kind of charge. Both are having opposite charges. This is true for any pair of objects that are rubbed to be electrified. Now, if the electrified glass rod is brought in contact with the silk for a while, if both the objects, glass and silk, are kept in contact, now what will happen? Now, if the electrified glass rod is brought in contact with silk with which it was rubbed, they no longer attract each other. Now what will happen? Whatever charges were established, okay, they will transfer or they will neutralize each other's effect. So what will happen? They will not attract each other. Okay, they also do not attract or repel other light objects also. So now they are no longer electrified, or their electrification has been lost. Okay. Thus the charges acquired after rubbing are lost when the charged bodies are brought in contact. What can you conclude from these observations? It just tells us that unlike charges acquired by the objects, neutralize or nullify each other's effect. So one is one was positive, the other one was negative. Okay, now when they are kept in contact for some time, then these charges are nullifying each other's effect, or now they are no longer the electrified objects. Therefore, the charges were named as positive and negative by the American scientist Benjamin Franklin. Okay, as you have say plus 2, and if the opposite number is added, then they neutralize each other's effect and it becomes 0. So, one object must have positive charge and the other object, say if you have this as a glass rod, okay, this is your glass rod and this is your say silk cloth, okay, silk cloth, then one must be positive. Say glass rod is losing the electron when the silk cloth is rubbed with the glass rod, then this glass rod becomes positively charged and this is receiving electrons, so this is becoming negatively charged. If they are kept separate, then this glass rod will repel the other glass rod which is rubbed with the silk cloth, other silk cloth. So they are, you can say, charged. Okay. But when these two are brought in contact, then what will happen? These electrons will again transfer to the glass rod and they neutralize each other's effect, and now they no longer are electrified, or they will not attract the small pieces or other glass rod which it was earlier attracting or repelling. Okay, we know what when we know that when we add positive number to negative number of the same magnitude, the sum is 0. This might have been the logic in naming the charges as positive and negative. Okay, this might have been the logic in naming the charges as positive and negative. By convention, the charge on glass rod or cat's fur is called positive. Try to understand. Glass rod was rubbed with silk cloth. Plastic rod was rubbed with cat's fur. Okay, glass rod is having positive charge, then silk will have negative. Plastic rod is having negative charge, so the electrons from cat's fur must have transferred on the plastic rod, so cat's fur becomes positive. Now if you bring these two objects close to each other, then they will repel. Okay, but if you bring these two objects close, then they will attract. Okay, it's a very easy thing that you can understand. Okay, now the simple apparatus which is there to detect the electric charge is the electroscope, gold leaf electroscope. This is the figure. Very simple device it is. Okay, it consists of vertical metal rod. This is the vertical metal rod. Okay, housed in a box. This is the box in which this vertical metal rod is kept or fitted. Okay, with two thin gold leaf. These are the two gold leaves which are kept at the end, which is there inside the box. When charged object touches the metal knob, here this is your metal knob. Now, if charged object is touching this metal knob, then this is your metal rod. So what will happen? The charge will transfer, because metal is having an ability to pass the charge, because they are the good conductors. Okay, so positive charge will be established on both the leaves. Some positive charge will come here. Say this is your metal rod, this is the knob, this is the object which you are bringing. Okay, and this object is brought in contact when charge object touches. Say this is the object which is brought in contact with this. Okay, so the positive charge will transfer on this or gold leaf. This gold leaf will also have the positive charge on it. So what will happen? Both are having positive charge. They will be repelled. They will go away from each other. Okay, there will be more separation between these gold leaves. Okay, or they will be diverged from each other. Okay, so what will happen? This object which you have brought in contact with this knob, okay, is charged, or we can say this is having the charge on it that can be detected. Okay, so this is the electroscope which detects the electric charge, whether there is electric charge on the object or not, that can be found. Okay, more the charge, more the separation would be. Okay, there will be more separation if there is more charge. If there is less charge, then there will be a less separation between these gold leaves. Okay, to electrify a neutral body, we need to add or remove one kind of charge. Now the charge which can be removed from the body is only the negative charge. Try to understand. Your electron can be transferred from one body to the other body. Okay, when we say that body is charged, we always refer to this excess charge or deficit of charge. Now whenever the object is neutral, then there are same number of positive and negative charges. Now when this is charged, then either the electrons are removed from this body. If electrons are removed, then this becomes positive, and if electrons are added on this body, then this becomes negative. Okay, when we say that a body is charged, we always refer to this excess charge or deficit of charge. In solids, some of the electrons being less tightly bound in the atom are the charges which are transferred from one body to the other body. The electrons which are lightly bound or they have less bonding with the atom, these electrons will be removed. Okay, and because of the removal of those electrons, this becomes positive, and the substance which is receiving this electron will become negative. Earlier it was neutral body, this was also neutral, but excess or rather the electrons from this body, that is the first body, is transferred, or electrons are transferred on this other body, then the next other body, that is second body, becomes negative, first becomes positive. A body can thus be charged positively by losing some of its electrons. Okay, similarly a body can be charged negatively by gaining electrons. When we rub a glass rod with silk, some of the electrons from the rod are transferred to the silk cloth. Thus the rod gets positively charged and the silk gets negatively charged. No new charge is created in the process of rubbing. Try to understand, no new charge is created during this process. Only there is a transfer of charge from one object to the other. Also, the number of electrons that are transferred is very small fraction of the total number of electrons in the material body. All the electrons are not transferred from one body to the other. Some of the electron, very less amount of electrons are transferred. Also, only the less tightly bound electrons in a material body can be transferred from it to another by rubbing. This is a process of rubbing. Okay, this is a cloth which rubs the object. Now, less tightly electrons are just getting transferred. Say if this is a glass rod, then less tightly bound electrons are transferred from glass rod to the silk cloth. Similarly, when plastic rod is rubbed with a cat's fur, the less bounded electron from the cat's fur will transfer on the plastic rod. Okay, try to understand this part. Therefore, when a body is rubbed with another, the bodies get charged, and that is why we have to stick to certain pairs of materials to notice charging on rubbing the body. So these two bodies or two pairs of bodies which we have taken, glass rod with silk, glass becomes positive, silk becomes negative. Plastic rod with cat's fur, plastic rod becomes negative, cat's fur becomes positive. Okay. Now the new topic is conductors and insulators. Okay. Some substances readily allow passage of electricity from them, others do not. Those which allow electricity to pass through them is a conductor. They have electric charges that are comparatively free to move inside the material. Already they have the charges within them, and they allow the electric charge to flow through them. Okay, they have electric charges that are rather electrons. We know, we have already studied in the third chapter. Okay, the electrons are responsible for the flow of electric charge within the conductors. Okay, so these electrons are comparatively free to move inside the material. Metal, human and animal bodies and earth are the conductors. Most of the non-metals like glass, porcelain, plastic, nylon, then wood, etc., they are non-conductors or they are insulators. They do not allow to pass electricity through them. Most substances fall into one of the two classes stated above. Okay, when some charge is transferred to a conductor, it readily gets distributed over the entire surface of the conductor. In contrast, if some charge is put on the insulator, it stays at the same place. Okay, so when the charge is placed on, say, conducting body, then if electrons are transferred, then what will happen? They will transfer and they will spread over entire body. While you have a plastic, then the charges are not going to spread. If they are kept at some place, then they will remain there only. They will not spread throughout the surface. Okay. Charging by induction. Okay, this is a process. We have two metal spheres, okay, A and B, and they are having insulated stand. These stands are insulated. These stands are insulated stands. Okay, they are brought in contact as shown in this figure. Okay, now bring a positively charged rod near one of these spheres. What you are supposed to do? You are bringing, say, glass rod which is positively charged, and it is brought close to one of the sphere. Here this is brought. You are not touching it. So what will happen? The electrons, some of the electrons, not all, some of the electrons will be attracted towards this left hand side, or they will come this side towards the sphere A. So excess positive charge is left on the second sphere. So here positive charge is as if generated. Both kinds of charges are bound in the metal sphere and cannot escape. They will not come out. Electrons are not going to come out. This positive charge is not going to come out. Okay, but stays there. They therefore reside on the surface which is shown here in figure A and B. Okay, the left surface of sphere A has an excess negative charge. Okay, right surface will have excess positive charge. Okay, however, not all of the electrons on the spheres have accumulated, that I have mentioned. All the electrons are not going to come here. Okay, as the negative charge starts building here, when the electrons are coming here, then they are getting accumulated. Now if new electrons are coming, then this negative charge is not going to allow this new electron because they repel each other. Okay, so all the electrons are not going to come here on left hand side. Okay, so electrons are getting piled up or they are accumulated here on left hand side sphere, and due to that, okay, the electrons have gone or they have left the sphere B also, some of the electrons. Okay, so sphere B becomes positive. Okay, now separate the spheres by small distance. Okay, you just have to separate the sphere by small distance. Now see, there is a distance here between these two spheres. Now what will happen? Negative charge will be here and positive charge will be here. Okay, so both are having opposite charges. Okay, the two spheres are found to be oppositely charged and attract each other. Okay, now remove this rod. Just you take away this rod. Okay, this rod is taken away. So what will happen? The negative charge here on the left side sphere, okay, will be there residing on it. Positive will reside on this B and it will be redistributed, and the final picture would be like this. This particular sphere has become negatively charged and this sphere has become positively charged, and this is the charging without any contact. So it is charging by induction. Okay, thank you.